And for the second circuit, the first question, we had to calculate the total voltage. Always remember, guys, if they are in parallel, voltage is the same. So we can see we have a battery somewhere here, and then we have those two resistors. Those two resistors are in parallel with this. Okay. So if your voltage is not given, somewhere in your circuit, there will always be a current that is given. So the clue for this circuit, you were given that current, which is 1.2. That's the one that you needed to use. So look, study your circuit again. Where does this current come from? It's coming from this side. Always remember, guys, in any circuit, current flows from a positive point right around the circuit until it gets to negative. So that means this current 1.2, it's coming from this positive and it's approaching the negative sign. So that means it's flowing through the 14 ohm resistor and the 6 ohm resistor. So to calculate our VT, then we will say V series, because the two resistors are in series, is the same as the total voltage, because these two resistors are parallel to the supply, equal to, always, guys, current is I times R. Okay. What is the current then that is flowing there? It's 1,2. Then how much resistance is there? As we can see, it's two resistors. So therefore, use brackets. Then we had 14 ohms plus 6 ohms. Or else, if you want to, you can first add the resistors. If you want to, you could have said R series is equal to 14 plus 6 equal to 20, and then you take the 20 ohm and substitute here. But if you punch this in your calculator, it's going to give you 24 volts. Then you get your first answer. Okay. Then your second answer, we had to calculate the total resistance. Okay. For the total resistance, again, we use the same principle. If current is divided parallel, if current is in series, it means series. But where do we start? Always start away from the battery. So meaning, in this circuit that we are trying to solve, we had to start from the bottom, then go up towards the battery. Okay. So then we don't skip any resistors, meaning you can't take this resistor and add it to that resistor, because you'll be skipping the 4 ohm resistor. So we had to try to and solve the two resistors. If you look at the current from this side, it goes down, it splits. The mistake that I picked up from the one that submitted, they said these 1, 2, 3 resistors are all in parallel, but only 2 resistors are in parallel here, because when current goes down here, it splits twice. So only 2 resistors are in parallel. Then from the first video, guys, we said to get R parallel, we use this equation. Then you substitute your fractions inside the bracket. So it's going to be 1 over 12 plus 1 over 4. Everything to the power minus 1. This will give you 3 ohms. Okay. Then, like what we did earlier, if you can't see what will happen afterwards, always redraw your circuit. You have combined the two resistors and got 20. So that means above your battery, we can say we have one resistor which is equal to 20 ohms. Then below the battery, we have combined these two resistors as well. And we have now one resistor which is equal to 3 ohms. Then we still have that resistor there which is 3 ohms. Now, if you follow your current again from this point, we can all see now that the current here does not split anyway. It's flowing through the two resistors, which means in the second step, we must say R series 2 is equal to 3 ohms, the one that we calculated here, plus the 3 ohm value which is given to us. So therefore, it gives us 6 ohms. Okay. Then again, always go back to your circuit. If you don't know what to do, redraw your circuit. Now we will have something like this. We still have the 20 ohm resistance this side. Then at the bottom, we have now this resistance which is equal to 6 ohms. Then we have our 24 volts here. Okay. Then now every time, guys, there's a battery in the middle, your current will always flow there and it splits twice. That means these two resistors are in parallel again. So to calculate R total, we will say open bracket 1 over 6 plus 1 over 20 to the power minus 1. You punch this in your calculator, your answer will be equal to 4,615 ohms. then you get your total resistance. Okay. Then the third question, we had to calculate this current, I2. Okay. How do we get that current? Again, an advantage of redrawing your circuit, it's easier now to follow your circuit, because to get I2, we can simply come to this circuit at the bottom and say I want current that flows at the bottom. How much is the total resistance at the bottom? It's equal to 6. So to calculate I2, we could have said V over R equal to, my voltage is 24 volts divided by the resistance at the bottom was 6, equal to 4 amps. Or second method of getting this current, if you want to, you could have used, first calculate your I total, because we already have the R total there. So I could have said the total current of the circuit is 24 volts divided by 4,615, which will give us 5,2 amps. Then you must now use Kirchhoff's current law. If current flowing here is 5,2 and 1,2 goes up, how much current will be left to go down? Always remember, guys, current is like water. Assume that you have one main pipe that brings 5,2 liters of water. Then 1,2 goes up, so how much will be left to go down? Obviously, we have to subtract between those two. Then you could have said I2 is therefore 5,2 minus 1,2 amps, and you will still get 4 amps. So whether you use this method or you use that method, we are still getting the same answer.